Hello. Hello. I hope everybody's in and we'll be starting shortly. Great, kind. Okay. Kindly, once you get, kindly make sure you ask a question or introduce yourself using the Q&A section. This is going to be another session that we are going to talk about the sensors and the actuators. And today we're talking about the buzzer and the water sensor. So kindly hold on. We'll begin this session shortly in a minute, sure. Apparently, there seems to be low turnout today, but we will continue as planned. Today, of course, we are going to go ahead from the lesson where we left last time. It is a continuation of what we had last time on sensors and actuators. Remember, we talked about input and output. So input majorly is played by the sensors, because they are the ones which are supposed to be able to detect. They're supposed to detect the problem, and then definitely they are the same ones. Now, once they are able to, so they play that role of being more of an input devices rather than an output devices. So the sensors bring in the information is processed, then we want to bring the actuators now to probably do or act or probably implement some bit of tasks based on the feedback that they are getting from the sensors, or based on the information that's coming in from the sensors. So we've really been able to look at a couple of sensors, and today we want to look at not only the sensor, but we want now to bring in the aspect of having two things work together: the water sensor and the buzzer. And we want to see what would happen if the water sensor and the buzzer were put together. And remember, I think last time we were talking about this issue. We looked at the water sensor at large, and maybe what did we say about the water sensor? We said it is very easy to connect it because it only has 3 connections or 3 pins. One of the pin will go to the ground, that is particularly the negative, and then the plus definitely is supposed to get to the power, 5 volts from the Arduino board, and then we have the green one. This is the one that brings in data. It's written S. So if you get to see the S, know that you are now having, so it's green in color. And that's why I want to put green here. So it's green in color. This is the one that is used to bring in the data, especially when it is dipped in water. So I'm imagining if it is inside probably a glass of water, right? All right, sorry. It's inside a glass of water, and water, the way the water level is here, is how it now takes these levels and moves with them. So it's upon you to decide what level do you want to, where do you want to indicate probably low. Maybe here you can say it is low, and then when it reaches here, what do you say? Probably here we will say this is okay or medium. Okay, in the middle. So the middle, and then probably here now it is high. When it passes here, then it is so high, and when it is very high, definitely there must be, maybe it's going to pour, or probably it is going to waste, or it's going to be a problem. So you need to use, that's how we are looking at the water sensor, and that's the work we're going to do today. Even in our project today, we're going to have the water sensor dipped in water. And remember, last time I think we had programmed it to an extent that it was able to indicate using the monitor, using our monitor, it was able to indicate that it is either low or high. So today we want to add just a buzzer. So when it is high, meaning there's danger, meaning there's something that can happen. So what do we do in that case? Therefore, we want to add a buzzer so that the buzzer is able to be used to tell or to turn on, to be able to warn, because the buzzer is what we're going to use today. Now let us look a little bit about the buzzer. That is what I want us to look at. The buzzer. What is this about the buzzer? And Simon, there is a session here. Simon is asking whether there is a session today. Yes, there is a Arduino session today. So You didn't get webinar meetings and meetings. Okay. Simon, there is a meeting today, and I think let me just probably get you. I think the link for Arduino was also supposed to have been sent. Wow, how comes we did not send it to the team? If it did not come, then it is just a small mistake. But there was some meeting, sure. Let me just work on that. And of course, I thought Simon, let us reply here that yes, there was a meeting today. Great. So I think that is good. I thought probably you'd been told. Okay, let us get to the buzzer and look at the different buzzer we are talking about. Sorry for just that. I think I was responding to a message from one of the members that inquired whether we had a meeting today. Great. So look at what we have here. We are talking about the buzzer. These are what we're calling the buzzer. It's one, and you can see the difference. There's one that has the that the base is covered, and the other one, the base is not covered. You see, these are the two types of buzzer that we have in the market, and these are the two types that come with the Arduino kit. When you get to find the two coming in, of course, we have the jumper wires. That one is obvious, we talked about. Of course, the USB cable that connects to the Arduino to the computer. But majorly, I want us to look at the buzzer. The buzzer specifically is used to be in many applications, especially when you want to do the warning. When you play tones that really is warning, it's in almost every computer. When there's a problem, you'll hear the computer making some sound. When it is starting, or there's wrong start, or wrong connection, any error that you can see always is alerted using the buzzer, and that's what we want to use today. That what about if the water is full? How do we bring in? And maybe back again, just let me take you back and again, and you can see there are two types of buzzer. We talked about the one that the base is covered and the one that the base is not covered. The one that base is covered is called active, and the sound is a bit annoying when it's active, because it makes a very clear sound, clear tone. While the passive one, this one is usually the passive one, it is not as annoying. It has probably just a click sound, just a click, like. So whenever there's a problem, you'll always feel here, okay, have that do some sort of a sound like that. So we are going to see how do we connect them to any of the Arduino, any of the buzzer. You can connect it to the board, or the breadboard, or to the Arduino using the 2 pins. Remember, it only has 2 pins. One of the pin is positive and the other one is negative. So, and how do you determine which one is positive and negative? 2 ways. One, when you get the buzzer, there is a small sticker on top of the buzzer, and that small sticker indicates it corresponds to one of the pins. Indicates plus, so you'll see certain plus on that sticker. If it's not on the sticker, when you remove the sticker, even on the board itself, on the piezo itself, you'll find it is plus. I'll be showing you mine through the camera shortly, so that you're able to see all these kinds of stickers we are talking. I mean the way we are able to determine the polarity of the buzzer. Otherwise, some of them is very hard to know. But again, another better way of using, you can use the length of the pins. The pins, the legs, or can you see the legs? The pins, normally you'll find that in the pins, one is longer than the other. The one which is longer is usually the positive. In these small gadgets, you'll always learn that the one which is longer is usually the one that is considered as the pin, the positive, or the positive one. That's the one you really connect. Even when you're using LED, remember we're talking about the one which is longer, and that's the one we are using we have to see as that is a positive one. So today we are also going to see how do we get to understand which one is to be connected to the positive side and which one is the negative side. So you see, in this case, the yellow is the one that's connected to the pin, a digital pin, because it's a digital pin connected to pin 12. That's what we will also be doing. And then, of course, the other one is ground. The black one is ground. So this other one is positive and the other one is negative. But now the positive one is the one that is going to be able to be instructed, to be programmed, and therefore we connect it to pin 12. That is how we have seen. So it is very easy to connect the pin, the buzzer pins. And I want you to try. It's very easy to do that. I'll give you probably a break somewhere along the line so that we get it. Now back again to the types of the buzzers. I think I've talked about the passive and the active. And the difference is just basically on the base. You'll find this one is not broken. So when you buy it and you find those places, I think the photo here is not really showing well because it's like it's showing as if there's some kind of damage that took place, but it is not like that. It is usually very fine. This is left intentionally to show the difference between the two buzzers. One is active, which is fully covered. This is the one that makes a lot of noise, and the other one is passive. And if you look keenly on the board, you can see the polarities is written. This other one is written minus, and this other one is written plus. So you are able to tell which one is the positive and which one is not, which one is negative. So it's very easy. So you don't need to really be bothered to find out now which pin will I hook where, because in most cases that is usually the biggest challenge for many newbies, people who are new in this. They always find it so hard to connect the Arduino, and they just say, probably, how do I connect this component to the Arduino? Because probably they're having a problem with the polarities or with the pin. They don't know what goes where. But this is very easy. In fact, even on the active buzzer, I think there is a small indication here that shows probably this is minus, and probably there's another one here that shows this is plus. But I've said the best way is to look at also the length of the pin. If the pin is long enough, then that one is usually or longer than the other. Then the one which is taller or longer than the other is the positive pin. So I think this is very clear. Maybe, I don't know whether we can take time to look at, if at all you have it in the kit, you can have a look at it, and then you can really come to see this. Great. I think it's not bad to look at now, how do we connect? How are we going to connect? As usual, we've said in our project, we are going to connect the negative side on the ground, and then the positive side, we are going to put a wire connecting it to pin number 12. So we are going to use pin 12. And what are we going to use pin 12 to do? So that we enable this to be able to work. So probably maybe we need to, once you've connected like this, so I want you to connect, and I'm also connecting mine on the table here. Once we connect, and let me show you as I'm connecting, probably you can be able to see. So that you're able also to make, to see for yourself what happens when, okay, let me get probably a video so that you're able to see. Let me move. So, probably from the side, you'll be able to see. It's not clear, but we're talking about the purpose, and probably let us bring the whole screen. Network may not be good enough. you're able to see the whole screen now. And this is our water sensor, the one we'll be using. Of course, this is the Arduino, as we've always talked about it. Let me get something to point, maybe a pen. Right, so said this is going to be the water. This is a water sensor. Let me get the photos clear. So this is the water sensor we've been using, and we are going to combine the water sensor and the buttons here. This water sensor seems not to, the cable is not really well put, so it's disturbing me. Why should it disturb me? Okay. Doesn't want to stay straight. Okay, no problem. Okay, that is the water sensor, and you can see the lines on how this is how it detects that there is probably the water levels as they move along this. We are able to detect and give information. But what I want to talk about is basically the buttons. You see I have 3 buttons here, and out of the 3 you'll see that this one and this one, they have the back open, while this one, which is the back is a bit closed, covered, and therefore it means that this one is this is the active buzzer and this is the passive buzzer. Active and passive, so you can always look at them, and then I think maybe, don't worry, it is shaking, camera is shaking, but I think it is easier to see from here that then how do we determine? You can see the length. You can actually see the length of the buzzer. You can see one is taller and one is shorter. That the length of the pin, the buzzer pin, that the longer one is the positive one and the shorter one is usually the negative one. So when you're going to connect, ensure you remember. Now with this other kind, you'll always see it on top of it. So let me bring it closer to the camera so that you're able to see. All right, so you'll always see it. Yeah, you can see the plus. Yes, you can see the plus button. The section which is plus, you can always see it there. That one tells you that the pin under it is the positive one, because that's the one that is as plus. So it's very easy to find out which part is plus, which part is minus. So you are able to tell the polarity of that. So I think maybe it's very easy. And then when we are connecting, definitely we'll say that we'll connect. We'll start with this, the active one, so that we'll be able to get. Meanwhile, let us first of all disconnect the water sensor, and then we just use the active one, and we're going to use maybe the first pin here, or the line 10, the row number 10. And remember, the longer one is the other side. So once we fix it on the board like that, once we fix it on the board like that, then we okay. Then now next is connect. Of course, we know this is number 10, so this is the positive one. We connect to pin number 12. We say that one will go to pin number 12. And then we need to get another cable. This one should not be black. Let's use the red cable so that it's easy. So that it is easy, let us use the red cable. So we connect to pin number 12. And ground, which is which is this other side, black. this one goes to the ground. And ground on the Arduino. I think I brought some ground. Started making sound already. Something 12. Okay, great. Now that the connection is ready, I think it's because it has found some program which was running. Now let us go to the Arduino software and try and program this this buzzer so that we see how is it programmed. Remember, the same approach which I want us to use is the same approach we've been using so far. Let me just remove that and take this to live so that at least I take you back to the screen. Yeah, so at least you are able to see. So here we are again. This is how we are making the connection. I hope you are connecting with me. The space for you to ask question are there, so you can ask Q in the Q&A. Kindly ensure you ask questions so that we are able to see what you're saying. Great. So let us get you to the Arduino software. That's what I wanted, so that we get things done. So that is the empty software, and as usual, let me probably make the writing big. I don't know whether I just need to increase the font so that it's easy for you to be able to see it coming out clearly. So it's big enough. It's big enough. So there we are. Now we want to, as usual, we know that the buzzer is been hooked in pin 12, so we just write int, and we know we are talking about the buzzer, and we have hooked it in pin number 12. So we just initialize that, or rather we declare that variable and as int, and then we put it there in pin number 12. Then we have, what do we set up? Remember, as usual, here we're talking about setting the mode of the pin. So the mode of which pin? The buzzer pin. And how do we want it to be? We want it to be an output. Remember, an output like that. So we are done and good. So once we know that's the output, so what do we do with it? As usual, we just come and say, because now it's digital write, because it's let us use the digital write. Remember this, it's a very, very important code. Digital write, what do we want to write? So digital write. Then remember, when the code turns color, it means you are actually writing it well. So what do we want the buzzer to do? So we can say buzzer high. Remember, it's either high or low. And if I just, then we must have probably, then you have to give a delay of 500. Then, or put delay of 1000. Okay. Then you can copy and just paste there, and then, oh, this is in brackets, sorry, because the 1000 millisecond, which is 1 second, definitely. So we are expecting that to really do that. So terminating this. So once the code is now ready, let us verify our code. Save it as buzzer. You'll always be asked to save. Let me save that, and then let me verify the code. So we are verifying the code, and like, wow, the code is good. Therefore, if it's good, let us look at the tools, whether the Arduino is connected in the port. Yes, well connected. Now, let us now upload to the Arduino. So if we upload it to the Arduino, now you can see, you can hear it. Yes, it's just doing what? So delay, no delay. So, oh, it is writing high, high, high. Remember, look, high, high, high. If you want it to turn off, we put that low. So then verify and send. Now that's how we debug. We get aha. Now we can see it is for 1 second and high, low, high, low, high, low, high, low, high, low, high, low. So that is what this is supposed to do. That is the buzzer, and you can hear the way it's so annoying. That's the active buzzer. When you replace it with an passive buzzer, you'll hear the noise is not the same. It's different. So that is the code for the buzzer. Another type of coding, there are people who like not, instead of using digital write, they just, there is a function in there is a function in Arduino called tone. So instead of writing buzzer high, because high and low will only give you one standard kind of tone. But if you use tone, there are different tones. And you see, people have even used in their project to sing a song, like Arduino, like the buzzer can sing. You can use it to really come up with the first stanza of the national anthem, as I've seen people even writing tone. So if we put here a tone like 500, I don't know what that one sounds like, and then maybe I can even change this to 400 so that it is, and then now instead of saying digital write low, because remember we are using tone, here we are now saying no tone. Okay, no tone for the buzzer. We don't need to write low. This is already a function. This is the one that people use. If you want to have probably, let me reduce the number of time so that we can be able to hear, or even if I was to leave it the same way, delay. $500, sorry. That noise, don't worry, it will stop. And then we are given appropriate tone. So what is the tone here? The tone, which we are, let me verify the code and listen to the tone. How does the tone 500 sound like? That's how the tone 500 sounds like. That is how you can hear. That is tone 500. Leave alone the speed. What about tone 450? Verify. Let us see what tone 450 is like. Let us upload. So you can see do, do, do. So you can now look for do, re, mi, fa, so, la, ti, do. You can do that using the buzzer, and that's what other people have been able to do. So once you just get the number, I don't know whether 1000, what would tone 1000 look like? So we save and we upload and see what does 1000 sound like. That is how 1000 sounds like. So you have two options. Either use the warning tone, which is just basically a digital writing it, or digital writing it high or low or stuff like that. Now I want us to now add the water sensor. Remember last time we were working with the water sensor, and therefore we want to add the water sensor to the mix and see what really can happen with that. Remember again, water sensor, if you can remember very well, we had, let me just either bring it. Did we have the water sensor? I think what we had programmed last time is what probably let me look for so that we work with it. Yeah, we can even go to File, Open Recent, the water sensor. Is it really there? No, but okay. Or let us just connect. And now we have from the buzzer. Now let us just add again the water sensor, because seemingly that is a bit corrupt. I was not able. So always remember to save your files, because apparently it's not working. So here we are going to get the water sensor, and let me use capital sensor. So that is, and we are going to hook it to, remember we said it's an analog device, so to A5, we are going to hook it to A5, and that is exactly what I'm doing. Remember, it is the S that we are going to hook to A5. So let me see where that one is. And then if we hook to A5, what will we be doing in the water sensor? Then, of course, the water sensor, when we come to setting the modes, the water sensor will now set this, let's say, pin mode of the water sensor. Double O, so pin mode of the water. Now here, the water sensor. Water sensor, we're going, this is an input. Remember, is the one bringing signals from outside, because it's testing the waters and bring. So we have already step 2. We said step 1 is to always try as much as possible to, let me make this look a bit neat, to first initialize or define your variables, probably telling where you're going to use the pins. It's good to tell Arduino especially where the pins will be, so that the program runs knowing especially you're going to use pin A5 or pin 12, because there's a possibility if you just put 12 here or you put A5, we may not be able to tell what are you really using the A5 for. So it's good to use it like this, so that it's very easy for you to use it down here. And then we said that sometimes this input, for us to be able, or sensor, it's not sensor, sorry. For us to be able to look at it, we said we can make use of the serial monitor. Serial monitor, we said, is usually the one that helps you to be able to look at things from behind the scene, where maybe you are not able to see from the eyes what is really taking place. Sometimes you don't know exactly what is taking place from behind the scene, and that is what we want to use. And then even today we want to use this to be able to help us work on create something. That's what we said. Now when we came to this section, now we want to get the water level. What is the water level like? So probably we can have an int that is just for the water level, and we say it's going to be called water level. And then the water level is going to probably read the readings from analog reading from the water sensor. This one is going to read what is happening at the water sensor. Analog read, remember, digital write, analog read, analog write. These things we said you must really, so we said this is called water sensor. That is what we have. That is so it's going to read the inputs. What is coming from the water sensor? What is the water sensor reading? That is what this water level is. And then therefore we said, then we are going to use this variable called water level and say if the water level is on a particular level. So we said we use if statement if our variable, which we are calling water level in bracket, of course, if what happens, water level is less than 100. We said we had already done all this, so I'm just repeating so that you're able to see what should we do, because there's that block of I think here what you just need to write is not to, you just probably serial print, you just print in the serial. Let us use the serial definitely so that we look at it, that print line. That's not capital, sorry. Yeah, it's changed good, well. So we want it to indicate that the water level is low. So we say water, let me type it well. Water level is empty because there's no, probably there's no water in the tank. So water level empty, that is what is going to write. So water level empty, that's, we expect it to write like that. So let me copy paste this and then probably so that we have so that we paste it down here. Again down here. So we just want to have like how many levels? We can put 3 levels, remember. So it's either low, we can put here low, water level is low, and then water level is high. So we want our sensor to be able to say the water, because this is just a sentence to be read by a human being. So you don't need to put a lot of, then if, because the first if is here, the second if, we don't just put if, but we say else, because it's the next if, else, if, and then of course the other if also is an else, if, so that we know they're else. And then here we are talking about water level is minus 100. This one is, it is more than 100. But it's not, sorry, it's more than 100, but it is not. And we can say, and again we can say, but the same water level is not greater than or equal to 300. Just is less or equal to 300. Then what should happen? That one should say the water level is low. What about if it is more than now 300? Let us just say if it is 300, probably more than 310 or less 310, so that we don't really mix, because when it's 300 you can find it confusing whether to say high or low. So you give an allowance there so that if it is more than 310, you should be able to say high. And then remember, now we are bringing our tone here. So today so that's where we now want the buzzer to create. And I think what we need to use here, when it's high now, the buzzer should now sound. Okay, the buzzer should sound. And I think every other, let it test, because so that it doesn't write this all of a sudden fast, we can create some little delay here of 1000 of 1 minute, so that it types it and gives us 1 minute. Sorry, I'm going to stop shortly just to fix everything so that we are able to see what really happens. So again, here we are going to put a delay of 1000. When you're coding, you begin, because yeah, here there's already a delay. So we can want it, I think maybe instead of using the no tone, let us just use, so it's a warning, the very digital write. Let us use the digital write. digital right. Then we are just saying the buzzer, we want it to be high. Okay. Then we don't want it just to be high, but we want it to make a delay of 5 or after 500 seconds, half a second, and then again, and then turn. Sorry for this. It's very easy to forget that, but never forget. If you don't forget, this is not a very forgiving language like others, like HTML, very forgiving, but C is not forgiving. If you make any mistake, it will just it all right, so that we want it to put it off, to put the buzzer off. So remember, this one is say low. Great. Then probably put another delay here of 500. So I think that sounds good. So we are going to push it. Oh, there are mistakes where now we start void setup. So here we didn't indicate that. That is usually the most, so when we verify now, it is okay, and then we can now upload. And when we upload, we're using A5 as usual. Now let me see, where do we get? We need to power the, why we have not yet even put it on the water, so I think maybe there's a problem here. Wait a minute. So the white one is already there. So the red one goes to the red. Then the other one goes here. So because it is low, it won't really. So I'll be showing you what we are having. So, and I'll also open the monitor, because remember, the monitor shows the water level is empty. It's now showing the water level is empty, remember. So it's, the program is running, but there's no water. So let us get the camera so that we can live our camera. Right. So maybe we just have to camera. Have the camera at the same time. This. So that particular point, you're able to see the screen as the camera. Yeah, it's going online. It's coming. So yes, so you can be able to see the one, and then the camera is having a problem. Yeah, probably yes, you can see the word. And let me just send it again. Try sending. So the camera may have a problem. So let us try again and again, but showing empty. But let me just add water. If I can add water. So the send is a problem, but no problem. We will copy until we get either the camera to work, or we just keep trying. But all in all, let me now try putting water. Let me put the water sensor in the water, And as soon as the sensor touches the water, the reading goes low on the screen. You can look at the screen as the reading is going low. When it goes high, you can hear the buzzer making noise. When it's low, the buzzer has stopped. Now high, it really shows the alarm that, hey, the water is high. When it's low, again, low, there's no problem. The water is low, it's okay. And there's no problem with the water when it's low. And then when it's also empty, there's also no problem when it is empty. And soon it's going to be empty when we remove it totally and dry it up. It is going to read empty. So once it reads, yeah, so you see it started reading empty. It has started reading empty. And as it reads empty, you can be able to see that now the same thing is corresponding. So I think maybe it's good to learn, we've learned a lot today, that you can use the buzzer, you can combine a sensor and an actuator to be able to come up with a project. So this can be as a warning. You can, it's not hard to incorporate it in your project. As soon as it says high, definitely it detects and gives the high as the information. The buzzer turns on, as you can hear. You can remove it or reduce it, and then it's a bit low. When it is low, there's no problem. When it is high, it gives the warning. So putting it so deep, then removing it a bit so that it's not so much deep. It says low, and then once it is outside completely, then it says empty, and you can see that. I think it sounds well. Let me now answer your questions, because I think time. What's the role of serial begin statement? I think I've said the serial begin statement is just for you to be able to monitor what is happening. Sometimes when the sensor is working, sensor will always be bringing in data, but that data you cannot be able to look at it unless you have it printed. You have Arduino to print it somehow on the monitor inside. I mean, the monitor, it's like a monitor, you're monitoring that, because not all projects will require that you use a display. Probably you want to use a display, you want to have it fixed on a display so that you're able to see the thing there. But you see, there are many things that are taking place behind. What comes to the display may not be exactly what you want people to see. So in most cases, you can use the serial monitor to be able to monitor some of the things. It is when it works in the serial monitor that you now think of putting it on the display. Like now you see, we have, once we have seen now, it can be able to write water level empty. Then this kind of information, we are going to take it and use it and even display it in the 12. Remember, we talked about the 1202 or no 1602 display, LCD display. Now this information you can be able to push it there, or this information now you can be able to push it to the mobile phone so that somebody can be able to check the level of the water using their mobile phone. It will be right, it will just be indicating empty. But if you are near to the where the waterfall or the water point is, or the water tank, then you can be able also to listen to the buzzer warning that, hey, the water is high, and therefore you need to take action. So I think I've grabbed that. So it's a very good tool. You need to learn it. Serial monitor is a very good tool. You need to learn because it's going to help you a lot. Serial begin. It's just to initiate the serial monitor. And where we get the serial monitor, we said at the corner somewhere. I think when we were talking about the Arduino software, we talked about that particular part of the Arduino. And let me just try and get you exactly where the serial monitor can be found. Remember, when we're talking about Arduino, we talked about the Arduino software, we talked about the serial monitor, and I hope so. Probably if I can get it very fast, I'll be able to show you so that you're able to see where the serial monitor actually resides. it is. I hope with this one it doesn't come out very small. Right. So maybe that's not the one we are dealing with. So let me end that so that at least I show you this other one that has the serial monitor. So that section of the serial monitor is very important. You're going to use it. You really need it. You will need it because sometimes you really need to do a lot of work and you want people to be able to see what you are doing. So this is where the serial monitor lives. It's here, this corner. So when you click on that thing, or even if you go to tools, you're able to also open it up so that you're able to see what is happening behind the scene. What is actually happening from the sensor? You can be able to get the readings of the sensor, find out what is really happening with the sensor. It's just like doing so much pretest without really getting into so many details. Find out online what more you can do. This is just a shortcut. See some handle of search here, but in most cases, I think in the Arduino software itself, there are many ways of getting it. I think I've said at the corner, as you've said, and then we've also talked about even when you go to tools, and you'll find serial monitor always also there. Serial monitor also is at the tools section. So remember to take that on and be able to use it. I hope I've answered the question, and thank you so much for asking the question. What's the role of serial.begin? It's just the one that initiates the serial monitor, so that the monitor should be able to start monitoring for you what is happening on the background, and it's going to be to display. So it doesn't work alone. So at the mode here is where you set it up at this particular space, serial monitor begin. So it's like you're setting up so that it also starts monitoring for you. Once then whatever thing it's monitoring, it should be able to print. So it prints for you. Serial, print the line, print for me what you're seeing. So print for me, so it keeps printing. Even if you want it to print, and then you're saying, wait for 1 second and print again. Wait for 1 second and monitor and print for me. Wait for 1 second, monitor and print. That's what we are talking about. And when it's printing, you're able to see it from here. You can see what is printing here. That is the monitor. And then, because remember we have the low, so yeah. So print for me what you are seeing. That is what the serial monitor is all about. Thank you. I think maybe that's an opportunity also to learn about the serial monitor. You need to start using it very, very efficiently. It will help you in your work. Once again, thank you so much, and I hope that we will still talk about this some other time. Thank you so much. Let's get to the next one. I'll end session. Bye-bye.